We're going to use the vertex and intercepts to sketch the graph of the quadratic function. What we have here, the way this function is already written out, it is already in what we call vertex form. Your vertex form, your h value is the value of the number that is being added, subtracted with the x there, always opposite of what you see. And your k value is the number on the outside of the group. So your vertex here is going to be a positive 2. Remember, opposite of what you see. And the negative 1 on the end, exactly what you see. So if we were to plot that, we'd have negative 2, or positive 2, negative 1 right there. This being an x squared parabola, it's going to look like this, and it will look like this because we have a positive a value here. If you have a negative a value, flip the parabola over. Down the center of this parabola, you're going to have a line of symmetry. Okay, now more about these intercepts. The best way to find the intercepts is to take your original form, and let's clean that up. Let's FOIL it. So this will give me x squared minus 4x plus 4 minus a 1, x squared minus 4x minus or plus 3. This little 3 here on the end will always be your y-intercept. So your y-intercept as a point is 0, 3, which would put you right here on the graph. And then to find the x-intercepts, we'll take this expression after we FOILed, and we'll solve it for 0, and that'll help us find the x-intercepts. This will be x minus 3, x minus a 1. X minus a 3 will give us a 3 as a point, and x minus 1 will give us a 1 as a point. So here is 1, 0, and here is 3, 0. Now if you wanted to graph it, take advantage of your line of symmetry and take this point right here and reflect it over that line of symmetry. I think you're going to have some kind of tools during this test which will help you make a nice parabola. But if we were doing it the old-fashioned way, and there we go. Determine without graphing whether the function has a minimum or a maximum value. So we have this parabola here. We have a positive 5a, or positive 5 as our a value, and that is going to give us a parabola that looks like this right here. The positive means it's going to be this shape. The 5 means it'll be quite narrow. But this vertex down here is definitely going to be a minimum value. Down here, minimum. The function has a minimum value. The value is, now what is that value? We'll need to find a vertex. We have an equation or a formula for vertex. I'm sure you've forgotten it by now, it's been a while, but that was h is equal to a negative b over a 2a. Your b is going to be this negative 5 here, so that'll be a positive 5. And the a is that positive 5 up front. 2a would be 10, so we get a half. So the value is, don't know that yet, it occurs that x is equal to 1/2. Now what the value will be your k value, which is what you get when you take and plug the 1/2 back into the function. So be 5 1/2 squared minus 5 times a half. 1/2 squared is a quarter. We could do the fractions. This will be 5/4. Get a least common denominator between the 4 and the 2 will be a 4. 5 and 4/4, that won't change. 2 will change. You'll need to multiply the top by 2, so now we have 10. We have negative 5/4. And that will be what the value is. All right, so think about a parabola, and this bottom point here is 1/2, comma, negative 5/4. What is the domain of the function? Well, this parabola is a nice polynomial function. Everything is possible, okay, for the domain. The range, though, is going to be based on the y-axis. And your graph goes down to here, and then it's everything up. So your range is going to be above -5/4, and it'd be C here.